Knowing about exceptions makes you a better developer. You don't want to overuse them. You certainly don't want to underuse them. And when you're using code written by someone else that used them, you need to understand the consequences of that for you. The rule of thumb, exceptions are for unusual, of course, exceptional situations. That's what they really handle well. So your try sets up some context, knowing something might go wrong starting here, and I am the place that knows how to deal with it, no matter how far down the calling chain it happens. Somewhere way down the calling chain, you run into trouble. The throw is capturing information. Now, the standard exceptions we use, the only information pretty much that it captures is the string, which might as well be boy, you're stupid, and the type, like out of range or invalid argument. You can make your own exceptions that capture more information. If it would be really helpful to know, look, you tried to access element 99 and this vector is only this long, then you can write an exception class that carries more information around if you want. At the instance of the throw, that information is gathered up and given to the location that can solve it, which is to say the appropriate catch block that was paired with the original try. The catch blocks associated with your try are kind of offered the exception in turn. So there might be a catch for ints, a catch for strings, a catch for invalid argument, a catch for out of range, and so on. You can also take advantage of polymorphism by catching an instance of a base class that will match any derived class. So if you want to catch the derived or more specific ones first, make sure their catch blocks are before and finish up with the more general catch block that catches, let's say, exception. And remember to catch by reference so you don't get object slicing and you don't lose the type, which in the case of the exceptions in the standard library is really the only information that you have, so it would really be a shame to waste it. Now remember about unwinding the stack, but everything between the throw and the catch, anything that was locally scoped along that way, will be cleaned up. Its destructor will run. If it's just a solid object sitting on the stack, that's great, you're done, the destructor went off. If you're wrapping up some sort of resource like an open file or memory on the free store, it's also great that the destructor will run and clean it up for you. You know, if you have a vector of person objects, the vector's destructor will clean up all the individual person objects that were inside the vector. That resource acquisition is initialization really is sort of a clean lifestyle for managing these things in a world where there is exceptions, multiple returns, lots of ways out of functions. You're not always sure where the end is. Don't worry about it. When we leave this function for whatever reason, the destructors will go off. And as you've seen, that exception class in the standard library, super useful. You can expect to be catching things that derive from it, and you may also throw them, if you wish, in your own code and then catch them elsewhere in your code. Take advantage of the work that's been put into creating that hierarchy for you.